Hi, this is Mrs. Doris. This is Tuesday, November 4th, and this is warm-up 1, which will begin your warm-ups for Chapter 5. I'm not going to take the time to go through the warm-up if you are absent today. However, please pause the video right now and do these problems. Remember, for x, you can choose any values that you wish. However, in order to put it on the graph that I have provided here on the smartboard, you would want to choose values that would be close to 0, between -6 and 6. However, keep in mind your y value may not fit on the graph. So pick at least 3 values for x and then substitute them in for the x and solve for the y, otherwise known as the value of the function at x, or f of x. Lesson 5-1 is entitled Rate of Change and Slope. Our objective in this lesson is that students will be able to find rates of change from tables and, number 2, find slope. We are studying linear functions because they can be used to solve real-world problems. We have some vocabulary today. First of all, rate of change. Rate of change shows the relationship between two changing quantities. Slope is our second word.
Good afternoon, staff.
The next word is slope. Slope is the ratio of the vertical change to the horizontal change. Now, please note in our formula here, rate of change is equal to the change in the dependent variable over the change in the independent variable. There's a couple of ways that this can be said. The dependent variable goes on the vertical axis, so it's the change in the vertical distance over the change in the independent variable, which is the horizontal difference between 2 points. So since the dependent variable is on the vertical axis, that's why we call it the rise over the run, which would be the horizontal axis or the independent variable change. Rate of change, when it comes to an equation or a linear function, is simply the same as slope. So the two definitions that you see up above can be used interchangeably. Problem 1, finding rate of change using a table. Is the rate of change in cost constant with respect to the number of pencils bought? Explain. All right, well, let's look at the change in the cost. From 25 cents to $1 is a difference of 75 cents. From $1 to $1.75 is a difference of 75 cents. And from $1.75 to 3 is a difference of $1.25. Now we also have to compare the difference in the X, or the number of pencils. Excuse me. All right, so from 1 to 4 is a distance of 3. From 4 to 7 is a distance of 3. And from 7 to 12 is a difference or a change of 5. So to compare these two, keep in mind number of pencils would be our X. Our cost is going to be our f of x, or our y. Okay? And so we want the change in the dependent variable over the change in our independent variable. Well, our independent variable is the number of pencils, and our dependent variable is the cost. So we want dependent on top. So we're going to take the 0.75 and divide it by 3. 75 cents divided by 3 is 25 cents. Okay. On our next one, we have exactly the same thing. We have 0.75 divided by the 3, our independent variable, and that again gives us the same rate of change. So the last one that we want to look at is our last expression. So change in the dependent variable, $1.25, over the change in the independent variable, 5, and $1.25 divided by 5 is 0.25. So is the rate of change in cost constant? Yes, it is. In every case, when we took the change in our y, or our function at x, divided by our x, we get the same number. So the answer is yes. And we could explain this. Each pencil costs 25 cents. All right? Problem 2, finding slope using a graph. All right, first of all, I'm going to add arrows to my lines in this chapter. When we graph lines, you should have arrows at both ends of your line. Now, it doesn't matter which 2 points we pick, but we're going to find the slope by using points. So I'm going to pick this point right here and this point right here. And I want the change in the dependent axis, which would be my rise, over the change in my independent, which would be my horizontal axis. So let's take a look. From here up to this point, I went 1, 2, 3, 4 places. From here over to here, 1, 2, 3, 4, 5, 6 places. So my rise to run is 4 to 6, or we would always reduce a fraction that is not in lowest terms. Dividing numerator and denominator by 2, we would get 2 over 3. So my slope is 2/3. Now, I want you to note that if I picked this point and this point, and I can go either direction, my rise is up 2. My run is over 1, 2, 3. So again, I'm going to get 2/3 either way I go. Now, you may say, when you plot a point, you go left or right and then up. Can we do that? And of course you can. To go from this point to this point, you're going 1, 2, 3 over, and you're going up 2. But slope is defined as the rise being the vertical distance, which is 2, over the horizontal distance, which is 3. All right, let's take another example. In this case, we can pick any 2 points, doesn't matter. We'll start simple and we'll just take this one and this one. All right, so my rise from this point to this point is downward. 2 places. So we're going to call that -2 since I am moving it down. Then from left to right, I'm going 1 place. So my slope is -2 over 1, which simply reduces to -2. A slope of -2. Now, let's pick a couple of different points. All right, suppose that I pick this point and this point. All right, then my rise is 1, 2, 3, 4, 5, 6 spaces down, and my run, I'll put my -6 out there. My run is 1, 2, 3. And since I'm moving downward, that's a negative distance, and I'm moving to the right, that's a positive distance. So -6 over +3 will still reduce to -2. So it doesn't matter, again, which 2 points you pick. Now, question might be, well, can I go from the bottom point to the upper point? And the answer to that question is yes. If I start at this point and I go up 1, 2, 3, 4, 5, 6 spaces, that's a positive direction. But from here to get over to the other point, I'm moving left 3 places, which is a negative direction. And you'll find also that 6 divided by -3 is also -2. All right, so this brings us to the slope formula. You can use any 2 points on a line to find its slope. Point 1 is designated as x sub 1, y sub 1, and point 2 is designated as x sub 2, y sub 2. Now, our slope, which is the rise or the change in the vertical distance over the run or the change in the horizontal distance, it doesn't matter. Your book shows this formula for finding slope. And all this is the change in the y's over the change in the x's of your 2 points. Now, does it matter which point comes first? And you'll find, no, it doesn't. If I start with point 2, then I need to start with point 2 in the denominator when I find my change in the x's. And if I start with the first point, then in the denominator, when I find my slope, I have to start with the x coordinate of the first point as well. So let's see what this looks like. In problem 3, what is the slope of the line through 1, 3, and 4, -1? All right, we're going to first of all do that using the slope formula. So I'm going to designate 1, 3 as my x sub 1, y sub 1. So in other words, my first point. And I'm going to designate the other point, 4, -1, as my second point, x sub 2, y sub 2. All right, now I'm going to show you both ways and show you that it doesn't matter. But if I start with if I start with this point, 3 minus -1, that would be my change in my y's, which is the change in my vertical distance or the change in my dependent variable. Then on the bottom, since I started with the 3, I've got to start with the 1. And I will take 1 minus the 4, which is the x-coordinate of my second point. All right, so 3 minus negative 1 is the same as 3 plus positive 1, which would be 4. And on the bottom, 1 minus 4, or 1 plus negative 4, is negative 3. So my slope is negative 4 over 3, or negative 4/3. All right, let's do it the other way around. Now, suppose that I started with my negative 1 and then subtracted the 3 over, since I started with negative 1, I have to start with my 4 on the bottom and subtract the 1. Change in y over change in x. All right, negative 1 minus 3 is negative 4. 4 minus 1 is 3. And these two amounts are equal. All right, whether I put 4 over negative 3 or negative 4 over positive 3, they are both equal to negative 4/3, which is my slope. Now let's plot the points and draw a line through them and see if the slope looks like we expected it to. All right, so 1, 3 would be right here, and 4, negative 1 is right here. And I'm going to join the 2 points together with a line, putting my arrows at both ends. And I want to calculate my slope using rise and run. All right, well, my slope, my vertical change is 1, 2, 3, 4. Going downward, that's a negative 4. And then my run, 1, 2, 3. Positive 3. So I get negative 4 over 3. All right. Likewise, if I went from the bottom point up, I would be going up 1, 2, 3, 4, which is a positive change. But then I'm going left 1, 2, 3, which is negative 3. So I get 4 over negative 3. So you see, it doesn't matter which point you start with, whether you are plotting points on a graph and connecting them, or if you are using the slope formula. You should get the same answer. All right, problem 4, finding slopes of horizontal and vertical lines. What is the slope of each line? All right, well, we're going to do it both ways. First, we're going to do it with the slope formula. So I'm going to take my negative 3 minus the 2 over 4 minus 4. All right, well, negative 3 minus 2 is negative 5. 4 minus 4 is 0. And this is the kind of fraction, if you put this into your calculator, you get an error message. So we cannot divide by 0. And when we get a slope like this, then we say that it is undefined. All right, let's plot the points and see what that looks like. 4, negative 3 is right here, and 4, 2 is right here. And the line that connects those 2 points is a vertical line. Vertical lines have undefined slopes. Okay? And let me show you what horizontal looks like, and then we'll talk about, I'll share with you the little trick that I use to try to remember that. All right, in our next example, using our slope formula, I'm going to take negative 3 minus negative 3 over negative 1 minus 5. All right, well 3 minus negative 3, adding the opposite, I get 0 over negative 1 minus 5 is negative 6. And 0 divided by negative 6 is simply 0. All right, let's plot our points. Negative 1, negative 3 would be right there, and 5, negative 3 is right here. So when I join these 2 points, notice I have a horizontal line. All right. Now, it may be very easy to remember horizontal lines have a 0 slope. The way I like to think of it is I can run along a 0 slope very easily. All right? However, I would have trouble climbing a vertical slope. I can't do that without equipment. So that's why, or that's how it helps me to remember that vertical lines have undefined slopes and horizontal lines have 0 slopes. All right, let's review the concepts that we've learned today. First of all, and I'm going to put my lines on, or my arrows on, a line with a positive slope is going to slant upward from left to right. So as I move along this line from left to right, I am going upward. My next example, a line with a negative slope slants downward from left to right. So, whoops, putting my arrows on. As I am coming from left to right down this line, I will have a negative slope. All right? And we can prove this by taking a couple points, if you wish. Let's pick a couple where they look like they go through the grid lines here. My slope here would be up 1, 2, 3. 1, 2, 3, 4. So this would have a slope of 3/4, which is a positive number. On this graph right here, let me pick a couple points. Here looks like a couple of good ones. And coming downward, 1, 2, 3, 4, that would be a negative direction. And 1, 2, 3, 4, 5 is a positive direction. So I end up with negative 4 over 5. So my slope for a line that is going downward from left to right will always be a negative number. All right. A line with a slope of 0 is horizontal. Once again, I'm going to put my arrows on that line. Here we have an equation. The equation of this one, if you'll notice, every point on the line has a y-coordinate of 4. This point would be 1, 4. This point would be 2, 4. This point would be 3, 4. This point would be 4, 4. So our equation is y equals 4. On our next graph, we have a line with an undefined slope, and it is a vertical line. And again, I'm going to put my arrows on, and this line isn't right on the grid line, but what you'll notice is, well, all my x values on a vertical line are the same. This would be, we'll call that 3.5. So this would be 3.5, 1. This would be 3.5, 2. This would be 3.5, 3, and so forth. So the equation of this line is x equals 3.5, or 3 5/10, however you prefer to write it. All right, let's try some problems. Page 298 through 299, I'd like you to do 9 through 31, the odds, and also number 43. And after you've tried them, be sure that you check your answers.